Kīlauea is quiet right now, but scientists are not treating that quiet period as the end of the story. At the summit of one of Hawaii's most active volcanoes, the eruption has paused again. The lava fountains have stopped. The crater is no longer throwing hundreds of feet of molten rock into the air, and there is no major earthquake swarm beneath the summit at the moment. But the instruments are still watching, because beneath Kīlauea, the pattern that is repeated again and again over the last 2 years is starting to appear once more. The volcano inflates, then it deflates. The vents glow. Seismic tremor changes, and after enough pressure builds, another burst of lava can erupt from the summit. The U.S. Geological Survey's latest update says the next fountaining episode is currently considered likely between August 24 and August 28th. That is a forecast window, not a prediction of an exact hour, and scientists are very clear about that distinction. But the reason they can even narrow the window down to several days is because Kīlauea has been following a remarkably repetitive pattern. And the latest data show that episode 54 is likely coming. The strange part is that this volcano is not simply building toward one continuous eruption. It is behaving more like a system that repeatedly charges and releases. And once you understand that cycle, the glowing crater, the changing ground levels, and the strange pulses recorded by instruments all start to make sense. Kīlauea sits on the southeastern part of Hawaii's Big Island, inside Hawaii Volcanoes National Park. It is one of the world's most closely monitored volcanoes, and for good reason. Its summit rises about 4,091 feet above sea level, but the important machinery is far below that surface. Deep underground, heat from Earth's interior keeps rock hot enough to partially melt. That molten material, called magma, can move through cracks and storage regions inside the volcano. Most of the time, you cannot see any of that directly. But magma moving underground leaves clues. It can push against the surrounding rock. It can change the shape of the volcano. It can produce tiny earthquakes. It can alter the amount of volcanic gas escaping from the vents. And perhaps, most importantly for this story, it can change the tilt of the ground. That is where the instruments become crucial. Scientists at the Hawaiian Volcano Observatory use extremely sensitive tiltmeters to measure tiny changes in the slope of the ground around Kīlauea's summit. Imagine putting a spirit level on a gigantic mountain and then trying to detect changes so small that a human standing there would never notice them. That is essentially what these instruments are helping scientists do. When magma accumulates beneath the summit, the ground can slowly swell outward and upward. The instruments detect that inflation. When pressure is released during an eruptive episode, the summit can deflate. The instruments detect that too. And over the past several episodes, those measurements have created something extremely useful, a pattern. The current eruption began on December 23, 2024, but it has not behaved like a typical eruption that simply starts and continues without interruption. Instead, the activity inside Halemau'umau has been episodic. Lava fountains rise. They continue for hours. Then they suddenly stop. The summit deflates, the volcano enters a pause, then inflation resumes. The pressure builds again, and eventually another episode begins. According to the USGS, these fountaining episodes generally last less than 12 hours and are separated by pauses of 2 weeks or more. That cycle has now repeated dozens of times. The most recent event was episode 53. It began around 3:45 in the afternoon on August 12th. By the following morning, it was over. At its strongest, the lava fountain from the north vent reached approximately 500 feet, or 150 meters above ground level. That is roughly the height of a 50-story building. For several hours, the volcano was throwing molten rock into the air from its summit, and then, just as quickly as it began, the fountaining stopped. The south vent did not produce a major fountain during that episode, although it produced lava overflows beforehand. A newer west vent also showed activity, producing earlier overflows and intermittent flames during much of the eruption. The plume above the volcano reached approximately 18,000 feet above sea level, but most of the falling volcanic material remained inside the closed area of Hawaii Volcanoes National Park. Then the volcano entered another pause, and this is where the instruments become more interesting than the spectacle, because after episode 53 ended, the summit began to inflate again. The Wekahuna tiltmeter recorded about 10.1 microradians of inflation after the episode. Then the pattern changed. The summit began deflating again. That deflation is important because scientists have seen these short deflationary steps during previous pauses. In other words, the volcano is not simply following a perfectly smooth upward curve toward the next eruption. There are interruptions. The system inflates, then briefly deflates, then may inflate again. Those steps make the forecast harder, and that is exactly what happened this time. The USGS originally expected the next episode during an earlier window, but another deflationary step pushed the forecast later. As of the August 22nd update, scientists were looking at a window between August 24 and August 28th. The reason is not that anyone knows the exact day the volcano will erupt. They don't. The reason is that the instruments are showing a sequence that resembles what happened before previous fountaining episodes. And there is something fascinating about how scientists make this kind of forecast. They are not looking into the future. They are watching a physical system repeat itself. Think of a balloon. If you keep adding air, the balloon expands. If you release some of that pressure, it contracts. If you repeat the process over and over, you begin to recognize the pattern. Kīlauea is obviously far more complicated than a balloon, but the basic idea is similar. Magma enters or redistributes beneath the summit. Pressure changes. The ground responds. The instruments record that response. Then the eruption releases part of the stored energy. The cycle starts again, and the difference is that Kīlauea's cycle is happening inside a massive volcanic system where temperatures, gases, magma pathways, and rock deformation all interact. That is why scientists use several types of evidence at once. Tiltmeters tell them how the ground is deforming. Seismometers tell them about earthquakes and tremor. Webcams show changes at the vents. Gas measurements tell them what is escaping from the volcanic system. And satellite observations can reveal changes over a much larger area. No single instrument tells the whole story. But when several independent signals begin pointing in the same direction, the forecast becomes much more useful. Right now, one of those signals is particularly visible. Glow. The latest USGS update reported continuous moderate to strong glow from the north vent overnight. There was also weak, intermittent glow from the west vent. The south vent remained dark. At the same time, low-level seismic tremor continued, with occasional irregular tremor spikes. There were no earthquakes recorded in the summit area during the previous 24 hours. That combination is important. It means the volcano is not simply exploding continuously. Instead, there are still signs that the volcanic system remains active beneath the surface, even while the fountains are paused. And that is one of the biggest misconceptions about volcanoes. People often imagine that a volcano is either erupting or completely quiet. But the ground does not work that way. A volcano can be quiet at the surface while enormous amounts of heat, gas, and pressure continue moving underground. At Kīlauea, the scientists can detect some of those changes long before a new lava fountain appears. That is what makes the current situation so interesting. The volcano does not need to suddenly explode for scientists to know that something is changing. The instruments can see the buildup first. And this is also why the phrase "about to erupt" needs to be used carefully. Kīlauea is already in an ongoing episodic eruption that began in 2024. So the real question isn't whether the volcano will suddenly awaken from a decade-long sleep. It is whether the next episode of that ongoing eruption will begin during the current forecast window. And according to the latest USGS analysis, episode 54 is likely. But the exact timing depends on what happens next. The current deflationary step needs to end, then inflation needs to resume. The USGS says that before previous episodes, inflationary tilt has often rebounded rapidly at the end of a pause and continued for roughly 1 to 2 days before an episode began. But the deflationary steps themselves cannot be forecast reliably. That is why the window can move. Scientists can recognize the pattern. They cannot control the volcano. And they cannot tell you with certainty that lava will begin flowing at a particular hour on a particular day. That uncertainty is not a failure. It is actually one of the most important parts of modern volcano science. The goal is not to pretend that nature is perfectly predictable. The goal is to recognize changes early enough to understand the risk and respond appropriately. And Kīlauea provides an extraordinary natural laboratory for doing exactly that. Because this eruption has repeated so many times, scientists have something rare. They have a chance to compare one episode with another. They can look at what happened before episode 49, then episode 50, then 51, then 52, then 53. Each event adds another piece of information. Each pause provides another opportunity to study how the volcano recharges. And each new episode gives scientists another test of their models. That is why the next event matters, even if it looks similar to the previous one. A repeated eruption can still teach scientists something new. And there's another recent change that makes this episode especially interesting. During episode 53, a collapse pit formed on the slope behind the south vent and created a new west vent. That means the plumbing at the summit is not necessarily behaving exactly as it did at the beginning of the eruption. The volcano has changed. There is now another location through which magma and gas can interact with the surface, and scientists are watching that new feature closely. The west vent showed intermittent flames during the previous episode and weak intermittent glow during the latest observations. Whether it becomes more important in a future episode remains to be seen. That is one of the things the next eruption could reveal. And there is a bigger question hiding behind all of this. How long can this cycle continue? The answer is that nobody knows. Kīlauea has been erupting episodically since December 2024. It has already gone through dozens of separate fountaining events. But volcanic systems do not come with countdown clocks. The current pattern could continue. It could change. The pauses could become longer. The episodes could become different, or the eruption could eventually end. Scientists can monitor the system, but they cannot simply extrapolate the current pattern forever and assume the volcano will behave exactly the same way. That is why the instruments remain active. Every new measurement matters. And right now, the most important measurements are happening during the quiet period, because a quiet volcano can be easier to understand when you know what happened immediately before the quiet began. Episode 53 ended abruptly. The summit deflated. Then inflation returned. Glow remained visible. Tremor continued. The summit then entered another deflationary step. And now scientists are waiting to see whether inflation resumes strongly enough to begin another fountaining episode. If it does, the next phase could unfold very quickly. Previous Kīlauea fountaining episodes have sometimes gone from early warning signals to spectacular lava fountains within a relatively short period. And that is why monitoring is continuous. Scientists do not want to discover that an eruption has started by looking at a photograph after the fact. They want the instruments to tell them when the system is changing. And that is exactly what Kīlauea is demonstrating right now. The volcano is giving scientists a live lesson in how Earth's interior communicates with its surface. A tiny change in ground tilt, a change in tremor. A glow in a crater, a shift in gas emissions. Individually, each clue can seem insignificant. Together, they can reveal the behavior of an enormous volcanic system. There's also a practical reason to take the current situation seriously without turning it into a disaster story. The eruption is occurring inside a closed portion of Hawaii Volcanoes National Park. The USGS says the current alert level is advisory, with an aviation color code of yellow. That is not an indication that a catastrophic eruption is underway. It means the volcano is being monitored because activity is occurring. And the park is currently closed while officials continue dealing with conditions on the ground. There are still hazards even during pauses. Volcanic gases can remain dangerous downwind. Sulfur dioxide can react in the atmosphere to create fog. Hot lava can remain on the crater floor after an episode ends. And the unstable walls around the summit can produce rock falls or ground cracking. So the absence of a lava fountain does not mean the volcano is harmless. It means the current phase is different. And perhaps that is the most interesting thing about Kīlauea right now. It is not simply erupting, it is cycling. The volcano has spent months showing scientists the same broad rhythm again and again. Pressure builds, lava rises, fountains appear, the summit deflates, the eruption pauses, then the system begins rebuilding. Now the cycle is approaching another turning point. The next few days could show whether the latest forecast is correct. If the deflationary step ends and the summit begins inflating again, scientists will be watching closely for the signals that usually precede another episode. If the pattern changes, that will be important too, because a change in the pattern could tell scientists that the volcanic plumbing system itself is changing. And that is why this story is bigger than one more lava fountain. Kīlauea gives us something most volcanoes cannot provide: a repeated sequence. A huge natural experiment, a volcano that repeatedly shows scientists what happens before, during, and after an eruption. Every cycle improves our understanding of the next one, and somewhere inside those measurements is information that could help scientists better understand how magma moves, how pressure accumulates, and how volcanic eruptions begin. For now, there is no need to imagine an apocalyptic scenario. The evidence does not support one. The more interesting story is happening quietly beneath the crater. The ground is being measured, the tremor is being recorded. The vents are being watched. The gas is being tracked. And scientists are waiting for the next change. Kīlauea has already shown us that a volcano can appear calm while its internal system continues preparing for another event. The latest data suggests that episode 54 is likely between August 24 and August 28th, but the exact timing remains uncertain because the volcano has entered another deflationary step. So the next time you see images of Kīlauea glowing at night, remember what happened before the lava reached the surface. Long before the fountain appeared, instruments were already watching the mountain move. And if you want to understand the strange changes scientists are detecting on Earth while they're still developing, subscribe to Wide View. We'll keep following Kīlauea as the next measurements come in and see whether this latest cycle produces another eruption episode or something scientists did not expect. Because the most fascinating part of Kīlauea right now isn't the lava you can see. It's the invisible movement happening underneath it. And scientists are watching that movement one measurement at a time.